In this example, we use the app called Prism to measure the required rotation and translation along one side of a glass prism to achieve a given incidence angle and footprint position. For definitions, please refer to the instructions in the app's webpage. Let's assume that we have an equilateral prism made of BK7 glass and that the wavelength is set to 975 nanometers. First, we adjust the angle of the left vertex to 60 degrees. Then we adjust the angle of the right vertex to 60 degrees to obtain an equilateral prism. The wavelength scale is in microns, so we adjust the wavelength to 0.975 microns. Then we select BK7 as the glass type. Suppose that we want to set the laser footprint on the upper face halfway between the center and the right vertex. Suppose also that the internal angle is to be set at a known value, let's say 41 degrees. Notice that when we adjust the slider, a black line is tilted with the corresponding angle relative to the normal direction to the upper face. This line shows the direction that the refracted beam has to follow within the prism. Now we adjust our virtual rotation stage to rotate the prism so that we have a rough approximation of the incident beam direction in red along the direction of the black line. Now comes a resource that allows very fine adjustment of the external angle, the magnification slider and offset of the workspace. We magnify and offset to see in detail the relative orientation between lines. By doing this, we can precisely adjust our virtual rotation stage until a perfect match is achieved. We get approximately minus 29.40, minus 29.39 degrees. Let us magnify back to the standard size of the workspace and offset a little bit. Notice that our objective is to reach that red dot. To do this, we use our virtual translation stage to shift the prism in a direction parallel to the original upper face. We first make a rough adjustment, then again by using magnification and offset we can make very precise adjustments. The footprint position is expected to occur at the center of the open circle, which is the position predicted by the theoretical formulation. We can make very fine adjustments and enter values to even adjust the fourth decimal place. In this example, we got minus 0.2257 for the translation. In conclusion, we have set external angle to minus 29.39 degrees and translation to minus 0.2257 to get the footprint at the desired relative position of 0.25 to to the right of the upper face center at an internal angle of 41 degrees.